there, this is a lecture video for Math 1320 Homework 8. And you may notice that the first thing that you see right here is the quadratic formula. So take a moment to pause the video and write it down. Well, so exactly what the quadratic formula is doing is trying to help you solve for a trinomial. So say, for example, you have a trinomial that's like x squared minus 2x plus 4. This is just a quick example, so I'm going to zoom in quickly so you can see that. So you're looking for the trinomial. So here's an example of a trinomial. The reason why it's called a trinomial is because you actually have 3 items there. And a lot of times you can't factor it out. So that was just a quick example. So that's the purpose of the quadratic formula. Hopefully you can see the colors, but right here, we're actually use the quadratic formula for this one. And this is a trinomial where you have A is 1, B is negative 4, C is negative 6, and notice how it equals 0. So going back to your quadratic formula, you're going to substitute your values in. So here's your actual trinomial once again, which is in red. Now substitute A, B, and C in. So since we're following the formula, you have a negative, then right here is another negative. A, B, and C. So A was 1, B was negative 4, C was negative 36. So each step below, I am simplifying it all the way down. So we know a negative 4 times a negative 4 gives you a positive 16. Negative 4 times 4 is negative 4. But negative 4 times negative 96 gives you a positive 384. Notice right here, 2 negatives give you a positive. Simplify even further, 16 plus 384 gives you 400. Notice how nothing else changed. But this is a perfect square. Now, look this right here. This indicates that you're going to add and subtract because squares can be both negative and positive. So once we take the square root of 400, that's 20. So let's do the addition first. So we have 4 plus 20, which is 24. 24 divided by 2 gives you 12. Then it has the and part because that's the subtraction part. So now you have 4 minus 20, which gives you negative 16. Negative 16 divided by 2. But that can be simplified into negative 8. So you have 2 answers for that. Your 2 answers would be negative 8 and then positive 12. The reason why I wrote the negative 8 first, because think about if you're doing it on a number line, you're going from left to right. But there's another way of doing it. Your other way is by factoring. So once again, here's your actual trinomial. It equals 0. But right here. So this is where it gets a little bit tricky. You're trying to figure out what you can get that you can multiply that gives you 96. But if you add or subtract it, it can give you negative 4. Well, in module 6, it may have even been module 8. I'm not quite sure, so my apologies if I misspeak. But I gave you a factor table. So in that factor table, it's giving you everything that can give you 96. So quickly, I'm going to do that mentally. So I'm going to have 1 and 96, because 1 times 96 gives you 96. Notice how it's an even number. So you can do 2 times 48. You can also do 3. 3 can go into 96 32 times. Let's think about, can 4 go into 96? I'm not quite sure it can. So 4 can go into 96 24 times. Then, I know 5 can't get into it. 6 can as well. 6 is 6 and 16. 7 can't go into it evenly. And 8 can go into it evenly 12 times. And I think that's it. Yeah, that's it, because then the numbers start repeating themselves. So now that we have all that, we're trying to find something that you can multiply, give you 96, which were all of these. But if you add or subtract them, they give you 4. Well, there's only one that can do that. That would be this one. But here's where it gets tricky. If I was to rewrite this, so you can see where I got it from. So I have to factor it into a binomial, meaning there's 2 set of parentheses. Notice how you have 2 x's. So here's an x, here's another x. We just said that the factors of 96 will be 8 and 12. Here's where it gets tricky. Notice how that's a negative 4. So that 4 is going to take the same sign as your greater of these 2 factors. Therefore, that's why it's a negative and a positive. So don't get too confused on why I rewrote it, just that the answer was already provided for you at first. So this is where this part comes in. Notice how the initial trinomial equals zeros, where we're going to let each one of these individual binomials equal 0 now. So x plus 8 equals 0, and then x minus 12 equals 0. When you solve for x for each one, notice how you have the final answers. So therefore, your solution set, again, just like our first one when we did quadratic formula, is negative 8 and 12. Well, there's more to come, still pertaining to the quadratic formula. And now this particular example, even though you have the quadratic formula given to you, notice how it's not a trinomial. Now the reason why there is not a trinomial, because how many terms do you see on the left hand side? There are only 2. Now notice the prefix of trinomial. Think about a tricycle. Trinomial means 3. This is not that. So we're going to have to solve it a different way. Note there's not a b. Remember the quadratic formula has to have a, b, and c. Well, let's just solve for n. Well, if we solve for n, we know that we have to add the 12 to both sides. Therefore, we have n squared equals, and I forgot my equal sign, y'all, so my apologies. N squared equals 12. Well, to get rid of the squared, we have to do the square root, because the square and the square root cancel each other out. So if we do it on one side of the equal sign, we have to do it on the other. Well, right here, we have n equals plus or minus the square root of 12. Remember, whenever it's a square or a square root, it can be both positive and negative, because 2 negatives give you a positive. Well, let's break it down. On this side, we have the plus side. On this side, we have the minus sign. There are a lot of ways to get 12, but I did 4 and 3 because I was looking for a perfect square. Yes, you could have done 6 and 2, but you have to break down the 6 even further. So right here, we have the square root of 3. Square root of 4 times the square root of 3. They just both under the radical sign. We know that 4 is a perfect square, and what gives you 4 is the 2. Notice how the 3 is left under the radical sign. Same thing for the negative part. Both of them are under the radicals, so if I was to rewrite this to make it a little bit easier for you, that would be negative 4 times the negative square root 3. Notice how both of them are negatives. We know that the square root of 4 is 2, hence that's the negative 2. You really don't need that square root, you really don't need that negative because it's already out here. Therefore, that's your final answer. Here comes a more interesting part that you're going to not like. So take a moment. Have something to drink, like some water or coffee. You know, we're not going to school. You might have something else to drink. Who knows? But right now, you have another trinomial. But unlike general trinomials, which are in this format, which you have ax squared plus by squared. I'm just making up letters, y'all. Plus something. Or plus c equals 0. Notice how you're going in decreasing order for the exponents. So you had 2 x's, 1 x. I don't know my alphabet, y'all, so I'm so sorry. So 2 x's, 1 x's, and no x's. Well, this one right here doesn't have 2 x's. It has double that. So 2 times 2 is 4. So let's break this down. We're going to let y equal x squared, because that's what we're normally used to when we're using the quadratic formula, dealing with the trinomial. So wherever I see x, I'm going to replace it with x squared, or with a y per se. So wherever I see x squared, replace it with y. So now I have 9y squared plus 14y minus 8 equals 0. Notice how these two do not have any variables or x's, so I don't have to substitute it. Now using quadratic formula, your a is 9, your b is 14, your c is negative 8. Substitute each one of those values in carefully, as I did right here. This will be the ideal time for you to actually pause the video to see how I substituted and simplified. So we know that 14 times 14 gave you the 196. The 36 times the negative 8 gave you the positive 288. And then right here you had your 18. That 14 is still negative. Simplified even further, 196 plus 288 gives you 484. Notice how you brought down the negative 14 and 18. But the square root of 484 is 22. Once again, you have a positive and a negative. So for the positive part, you have negative 14 plus 22 divided by 18. That gives you 8 over 18 simplified to 4 over 9. Remember, this is dealing with x squared because that's what y was. Now we have the negative part. Negative 14 minus 22 gives you negative 36 over 18, which gives you negative 6. So here's your negative part of your x squared. So again, make sure you pause your video so you can better understand this, because it gets more complicated. Now you have to go back to your y equals x squared. So x squared gave you 4 over 9, and it gave you negative 2. You may recall that if you're trying to cancel out a square, you do the square root. So now I got the square root of 4 over 9. Then I have the square root of negative 2. Well, if I break this down, I'm going to have the positive square root of 4 over square root of 9, which gives you 2 and 3. My 9 looks like an A, y'all. So that's where the negative and positive come from. So that's 2 answers. Then we have to come over here, dealing with imaginary numbers. Remember that the no negative can be under the the radical sign. I'm human, y'all. Don't kill me. In case you don't know what the radical is, I'm talking about the square root. So since our negative is under the radical, we factor that negative out. So because you got the plus and the minus, technically you just got I, square root of 2. So we're going to break it down right here. One is going to be negative and the other one's going to be positive. Now remember, you had 4 exponents. That was your highest exponent. Remember that x to the 4th power? Well, that was a hint to how many answers you're going to have. You got 1, 2, 3, 4 answers. So your largest exponent determines how many answers you're going to have. Now here it gets a little bit simpler. Remember, reading is fundamental, so be careful. There's a lot of reflection going on, so my apologies. It's saying that a set of ordered pairs are a function. Now another way of remembering that is your input and your output, where your x values do not repeat. So a function determines whether your x values are repeating or not. So here are your ordered pairs that are given to you. You have 2 and 5, 3 and 8, 4 and 11, 5 and 14. I'm a visual learner, so notice how I actually have to label each one of these. Now notice that none of your x values repeat themselves. So you got 2, 3, 4, and 5. Now because none of the x values repeat them, that makes these ordered pairs a function. So again, a function is, ordered pairs are considered a function when the x values do not repeat. Ugh. More square roots, yay! So here it gets a little bit more complicated, but not too much, because you can always use MathWay or use your calculator to input this. When you do this, I'm going to show you just one example of it, so you can have a better understanding of it. But I prefer MathWay. Here's your actual function. So this is your equation, square root of 4x plus 3. What it's asking you to do is find f of 13 over 4. Well, what in the world does that mean? Well, let's simplify that by substituting. So wherever you see an x, you're going to substitute that as. So in your initial equation, you got 4 times square root of 4 times 13 over 4 plus 3. So those two 4's are going to cancel out. 13 plus 3 is 16. Therefore, the square root of 16 is 4. Next, you have 5. So wherever you see an x, you're going to substitute 5 as your x. So remember, what you see in blue was your initial equation. So let me zoom back in. So 4 times 5 is 20. 20 plus 3 is 23. Do not simplify it. Let it stay that way. So now we got two answers. We got 4 and the square root of 23. Your last part is asking you to substitute x as negative 1 over 2. So notice how I substituted in right here. The 4 is divisible by 2. Therefore, you're going to have 2 times negative 1 plus 3. Where 2 times negative 1 gives you negative 2. Negative 2 plus 3 gives you 1. Square root of 1 is 1. So this particular problem in the summary is all dealing with substitution. Ooh, I'm saying ooh a lot so y'all can understand it and know what to look forward to when you're actually doing it. Here's a word problem. Now I've already had it set up for you. And I'm trying to zoom it in where you can actually see it, but that's kind of difficult at the moment. So let me read it. It says, suppose that a car rental agency charges a fixed amount per day plus an amount per mile for renting a car. Heidi rented a car one day and paid $92 and 190 miles. Another day she rented a car from the same agency and paid $137 for 340 miles. Here comes the math part, y'all. Find the linear function where x is in miles and f of x is in dollars that the agency could use to determine its daily rental charges. So here's your answer. 0.3x plus 35. Let's see how we got that. So first of all, we got our ordered pairs. You have your ordered pair of 92 and 190 and 137 and 340. It is telling you in the problem itself where x and f of x are going to be. Well, I don't like saying f of x. It reminds me of the network. I don't know why, but it just does. But I'm going to add this as x1 and y1, then x2 and y2. Remember, x were in miles. So I rewrote that down here. It's given that x are in miles and f of x are in dollars. So here we go. x1, y1. x2, y2. I made a mistake up there, so that's why it's always good to make sure you read it. So x was in your miles, your f of x is your money. So now that I got my 2 points, let's figure out how I'm going to do that now. So you may remember this from a while back, but we're going to use our slope formula now. So when we're using the slope formula, we're going to substitute our values in. So we have y2 minus 92, then x2 and x1, which is 340 minus 190. That can be simplified by 15, which is 3/10. So 3/10 is the same thing as 0.3 as a decimal. Now that we got the slope out of the way, now we're going to use the point slope formula. So substitute your slope, which is your m, which is 0.3. And we're going to substitute that first point, which was 190 and 92. So, right here is the formula itself. Now we're going to substitute x1 and y1. Here we are right here with the 92, the 0.3, and the x1. Now we're going to use distributive property. So whatever's on the outside, multiply it by what each term is on the inside. So on this line right here, you got y minus 92 equals 0.3x minus 57. Remember that 57 came from 0.3 times 190. We're trying to get the y by itself, so add 92 to both sides. So once we add it to both sides, this is your final answer. This is actually your linear equation. But make sure that you go back to the problem itself. It didn't say anything about y. it says your function. So notice how y and f of x are the same thing. So it's calculator time now. So these graphs each have a certain type of characteristic. When it's curved like this, look like a very, very stretched out S, you know it's going to be to the cubed root. So we're going to see what we can do to use our calculator to get this. So I'm going to zoom in so you can see the problem a little bit more clearly. There it goes. So right now, write this down for me. And the reason I want you to write it down, because shortly we're going to use our calculator to input this exact same equation in. So let's go to our calculator now. Let me zoom back out. Alright, awesome. So, since we want to graph an equation, my finger is hovering over the y equal sign. So we're going to hit y equal. And if by chance you have anything in there like I do, just hit clear, which is right here. Now we're going to type the equation as we see it. So the first thing you see is your open parentheses. So let me zoom back out so you can see everything that I'm hitting. So open parentheses, your x, then your minus sign, then your 5, then close your parentheses. Using your caret key, and again, make sure that you're looking at my fingers. Then we're going to hit the caret key, then 3. Now, depending on what version of your calculator you have, some of you may have an arrow. You probably can't see the flashing, but it is. Some of you don't. You probably have to do it on trial and error. But now I'm going to hit my arrow key and then hit -2. Hit enter to lock it in, and notice how it goes directly to Y2. So now it's time to graph. In the upper right hand corner, I want you to hit graph. And voila, there it is. Now different people again got different versions of the calculator, so I'm going to hit the zoom key and go down to zoom standard. This is only for those who don't have quite the exact same thing. You're going to get the exact same graph. Now I want you to pay close attention to something. Notice how everything is on the right hand side. And you can use your arrow keys just like if you were texting. And let's see where this line crosses the x-axis. So notice how the numbers are right here. And if you were to round it, it looks like it's going to be a 6 right there. So let's go back to our graphs. We know it can't be this one because it's on the left hand side. Can't be this one. It's also on the left hand side. So we're stuck with either this one or this one. Remember when I was saying pay close attention to where it crosses the x-axis? Well, that means that this one is going to be your answer. Let's do some more exercises dealing with graphing. Here goes another one. And again, you have to be very careful when you're doing it. So look at all 4 answer choices. Notice where they're directed. So let's try. But before we do that, let's zoom in on the actual equation itself. So take a moment to write all of this down. Calculator time now. So let me zoom back out so you can see what I'm doing. Okay, so to graph it, let's do y equal. This is our previous example, so we're going to hit clear to clear it out. Now going back to the actual problem, it said square root. So we're going to hit our second key, which is this key where my finger is, that one, and then the one with x squared on it. That's your square root. Now we're going to put in x. Again, you can't see my finger. Here goes x. Your plus sign, then 4. Now notice how I have an arrow. Some of you don't have an arrow, but you're still going to hit this right arrow key to get away from that radical sign. Now we're going to hit -6 and then enter to lock it in. Once again, we're going to hit zoom, then go down to zoom standard. You now have your graph. So notice where it is crossing the y-axis now. So I'm still going to use my arrow keys. So I'm looking at y. So y looks like it's going to be right at -4 if I round it. So it's nothing on top, and it's crossing the y-axis at -4. So let's look at our graphs to have a better look at it. So we know it couldn't be this one because it wasn't on that side, nor this one. So now we're left with either this one or this one. And your correct answer would be this. Whoop, whoop. You can see the writing now. That means we're doing a whole bunch of other stuff that we didn't want to do. So, while I'm talking in this funny voice, you need to take something to drink and just woosah for a minute. Because let me zoom in and let you look at the actual problem. It wants you to add, subtract, multiply, then divide all of the f and the g's, where f of x is -5x minus 6 and g of x is -3x plus 7. Notice I've already given you the answer, but there are two parts to it as well. Not only do they want you to know what the sum, the difference, the product, and the quotient are, they also want to know the domain and range. So let me show you what to do. In regards to the domain, that's dealing with your x values when you graph. In regards to the range, those are your y values when you graph. So let's figure out what we're graphing first. So here's the first part where we're adding the -f5x minus 6 and the -3x plus 7. So I'm just using your parentheses so you can know exactly what you're doing. The first step is that I'm grouping my like terms, so that's the ones with the x's, and then the ones without the x's. So now once I simplify, I have -8x plus 1. But now we have to determine what the range and domains are. So going back to your calculator, I'm going to hit the Y key, hit clear. Now I'm going to hit type in 8x plus 1. Go to zoom standard, and then you have a line. Well, this is a representation of a linear equation, but if I could make this screen a whole lot bigger, including your computer screen as well, notice how it keeps going and going and going down in this direction, which is going to be -infinity, and it keeps going up, 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 up in that direction. Well, that means it can be -infinity and +infinity. What that represents is all real numbers because it's going infinitely in both directions. Your next one is dealing with the subtraction portion. So here we go with the subtraction. Notice how it's already giving you the answer. So now we're going to subtract -5x minus 6 and -3x plus 7. Notice right here though, this is the same thing as your distributive property, because everything that's following this negative right here is going to do its opposite. So the two negatives make a positive, and that negative will make that a negative. Combine your like terms once again. So now we have -2x minus 13. We have to determine what the domain is. Remember, you're looking at your x values. So we're going to go back to the calculator, go to y equal, clear out your previous problem, and we're going to do negative, not minus, negative 2x minus 13. Hit enter to lock it in. We don't have to do the zoom standard anymore, so we can just graph it. And notice this one. It's still going up, 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 up in the negative direction, but it's going down, 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 down in the positive direction. What I mean by positive, notice how it's going right. That means it's getting bigger and bigger. So since it's going infinitely in both directions, that one is also real numbers. Now we're going to the product. So the product is a little bit different. So here's your answer right here. You have 15x squared minus 17x minus 42. And what we're going to do is use the FOR method to get it. So let me zoom in just a little bit, but not mess up too much. So far, the first two examples were just plain old x's. So hopefully you can see my pen right here. That's just one x, meaning it was going to be a straight line. But our final answer right here has two x's, meaning it's going to be a parabola. So we already have some idea of how it's going to graph. Well, right here, let's figure out what we're graphing first. So multiplying, we're going to use a FOIL method. So first, outside, inside, last. Once you do all that, you're going to combine your like terms, especially these two right here. And your final answer is 15x squared minus 17x minus 42. So let's graph it to make sure we know what our domain is. So once again, hit the Y equal key, hit clear. Then you're going to do 15x squared minus 17x minus 42. Hit enter to lock it in. Go ahead and graph it. So you can't see where it's a parabola. So I'm going to do a little, thing for you. And you can't do this, y'all. So don't you try it. Don't you try it. Don't you try it. Don't you do it. So ta-da! You got your parabola. Same thing as U. So this is also going to be a domain of real numbers because if you're looking across from left to right, if your screen was big enough, it'll keep going bigger and bigger and bigger and bigger in the left direction and bigger and bigger and bigger and bigger in the right direction, meaning that that's going to be infinite in both directions, therefore all real numbers. But now we have to find the product, which is this last part. So you have negative 5x minus 6 divided by negative 3x plus 7. You really want to simplify and factor out those x's, but you can't because the x's are not in both terms. So this is your final answer. Leave it alone. Don't touch this. Don't touch this. But I want you to pay attention to something. Notice the denominator. Now what I mean by the denominator, notice the bottom part, you got negative 3x plus 7. What would make that a 0? Well, let's make it equal 0. So you got negative 3x plus 7 equals 0. Subtract 7 from both sides. Now you got negative 3x equals negative 7. Divide both sides by negative 3. So two negatives give you a positive. Therefore, 7 over 3. But remember, x cannot be this, for the fraction then would be negative 5x minus 0. So, for your domain, and I'm going to write it a little bit different, you know that x cannot equal 7 over 3. They just want you to write that properly out. We ain't worried about that. We just know that it cannot be 7 over 3 because then you're going to say that you got this many parts of nothing. Nobody wants nothing. Unless you didn't on a diet. But anyway, I digress. Moving right along. Here goes another function. Now what these are called composites. Now the reason why they're called composites because they're going to be a part of each other. So you have your f of x, which is 5x squared minus 2x minus 1. Then you have your g of x, x plus 4. So the first one wants you to substitute your g of x in the f of x. So wherever I have an x, I'm going to put x plus 4. So now I got that. So substitute x plus 4 into f of x wherever you see x. So that's what I did right here. Now I got to expand it. This is x plus 4 squared. That means I'm going to use my FOIL method. So in order to use FOIL method, remember that's first, outside, inside, last. So I got x squared plus 4x plus 4x plus 16. Simplify that. That's going to be x squared plus 8x plus 16. Next, I'm going to put it back in where I had it initially. Now, remember where this 8 came from. This is a distributive property. So negative 2x gave you negative 2x. Negative 2 times 4 gave you the negative 8. Bring down your negative 1. I'm going to simplify it. So once I simplify it, I have 5x squared plus 40x plus 80 minus 2x minus 9. And if you want to know where I got all of these numbers, I use the distributive property right here. Because wherever it's on the outside, you got to multiply by each term on the inside. So that's where the 40 and the 80 came from. Now simplify it by combining all your like terms. So I know 40 minus 2 gives me 38. And then the 80 minus 9 gives me 71. This is my final answer. But I got more. Oh, here's a word I forgot. I know it was a parabola because I got that x squared right there. And because it's a parabola, you know that it's going to have a domain of all real numbers. Sorry, I forgot about that. But wait, there's more. Now we got to do where you substitute f into g of x. So once again, f of x is 5x squared minus 2x minus 1, and then we got g of x plus 4. So wherever I got an x and g, I'm going to put all of f of x in there. So that's what I did right here. Then I simplified it because negative 1 plus 4 gives you positive 3. And once again, it gives you another parabola. And I knew it was a parabola because I see this squared. So that means your domain is going to be what? All real numbers. Woohoo! And we're moving right along. Yeah. So let me zoom into this one. So take a moment to read it, and I'm going to try to slide it very slowly so you can understand it. So it's asking you to translate the statement of variation into an equation and use k as the constant of variation. So what it wants to know is what type of equation will you have where y equals something that directly varies with the cube of x. So let me put it in layman terms. Direct variation means that as x increases, y also increases. For example, if your appetite increases, then your weight increases. That's a direct variation. But you want to know where all this came from. Well, we know it has to be an equation because that's what it said. Therefore, y equals. You also stated that it wants k to be the constant, so that's where the k came from. But right here, cube of x, that's where the cube of x came from. Do not solve anything. Do not substitute anything. This is your final answer. So some of you might say as y varies directly with x, that's just going to be kx. Because the k always going to be there. It's always going to be a constant. Now the opposite of direct would be, would be indirect. That's going to be called the inverse. So if you're looking for the inverse of it, give me a moment because I have misplaced my sheet, which is so inconvenient for me. So this is time for you to just sit there and talk about me quietly because this is recording. I don't know what you're saying either. Be nice if I had some elevator music, but I don't. No elevator music. Well, good gosh almighty. That kind of sucks. Okay, so we're going to have to improvise. So if it's an inverse, so thank you for your patience. Inverse variation means as x increases, and the opposite of increase will be what, y'all? Decrease. A good representation of that will be y equals k over x. Now the reason why you're doing that is because it's the inverse. So that means they're opposite of it. It's almost like a reciprocal of it. So if I ask you to find the inverse as I'm thinking now. So if I want you to find the equation of inverse variation of y and of x squared, and let k be the constant, the way that it would be written will be y equals k over x squared. Now 12 and 13 and 14 are also dealing with those, but I can't find them, and I'm having a flustered time and trying to find them, because that's going to be to your disadvantage. But we can always use MathWay, and you can always email me or send me a text about it, but it's very similar to what we just did for number 11 and 12. So 13 and 14 are going to be examples of that. So you're going to have to substitute the numbers into those too. So make sure you read the problem carefully, and I can gladly help you via email or that. But we got one more to do before the video runs out. Number 15 is dealing with inverse. Remember that inverse variation we were talking about right there? So here it goes. It says find f of negative 1 power. So it means find the inverse. Almost like a reciprocal, but it's not. So here's your given formula right here. This is your equation. F of x equals 6x minus 1. Well, the first thing we're going to do, we're going to rewrite it. We don't know what f of x is other than the function. So we're going to rewrite what we have, y equals 6x minus 1. Your next step, you're going to switch. I can't spell, apparently. That's why I teach math sometimes. Next, switch x and y. So wherever you have y, put in x. Wherever you have x, put in y. So now we got to do the tricky part. Solve for y. So x equals 6y minus 1. Okay, so the first thing we're going to do is add the ones to both sides. So if I do it on one side, I do it on the other. So the ones cancel each other out. Next, I'm going to divide both sides by 6. So notice how you got to divide all of that by 6. So just rewrite it as a fraction. So your final answer is going to be x plus 1 equals 6. So if you want to get technical with it, that would be f negative 1 equals x plus 1 over 6. So ladies, gents, individuals, thank you for suffering through me with this, but this is now your video lecture for homework 8.